Hello, B96.1, you're on the air.
Yes, I would like to learn about how it is being a hydrologist.
Wow, that's a very complicated question. Let's go deeper into it. Before we even get into how is life being a hydrologist, we must know what hydrology is. Hydrology is the study of water. Hydrologists are people that study water. Hydrologists study many things like the water cycle, ocean topography, and many more.
How does evaporation work?
Evaporation is a very easy process. It's basically where the sun's heat heats up the water and it turns the water into water vapor, which then sends it up to the atmosphere. Without the sun, evaporation would not be able to happen, and there would be no water cycle. Then you have condensation. That's when water vapor in the air cools down, which is also the formation of clouds. That's also a very easy process too. But during condensation, you do not know where the water vapor will end up. Evaporation could happen in the Pacific Ocean, then come down as precipitation in the Atlantic Ocean. Then you have precipitation, the easiest of them all. Precipitation is basically when that water comes down from the clouds. It's basically when the clouds get too full of water and they just pour down. Basically rain, sleet, snow, and hail. Those are the four types of precipitation. So now the last stage, which is runoff, aka collection. You guys probably already know about this because I recently said it in the beginning. It's basically where water comes down onto the earth and then it goes through rivers, valleys, and streams and lead up to bigger rivers. The water cycle is not the only thing that hydrologists study. Hydrologists also study the amount of fresh water and salt water on the earth. Our Earth is mostly covered in salt water, with 97% of the Earth's water is salt water. Meanwhile, 3% is fresh water, which is also how much we have to use. This is why the conservation of water is very important. When you're brushing your teeth, be sure to close the faucet and do not let it run, because we only have 3% of our fresh water and only 1% is available to us because 2% of it is frozen in the North Pole and the South Pole. Many people learn about hydrologists through standards. I will be covering many standards today. The first standard, Standard A, says explain the role of the sun as the major source of energy and its relationship to wind and water energy. This basically means to tell the role of the sun in the water cycle and explain how does it relate to the wind and the water. The sun plays a major role in our studies of hydrology. Many people think that hydrology is only studying water. But also the sun plays a very, very, very important role. The sun is really what causes the water cycle to go into effect. Because without the sun, water vapor would not be able to get into the atmosphere because only the sun has enough heat to heat up the water to bring it up into the atmosphere. The second standard, which is Standard B, says identify renewable and non-renewable resources. Before we get deep into that, we must know what a renewable and a non-renewable resource is. A renewable resource is a resource that can be used again or reused. Some types of renewable resources are geothermal energy, wind power, biomass, wind turbine, solar power, hydropower, and tidal power. Now that we know what a renewable resource is, we must know what a non-renewable resource is. A non-renewable resource is a resource that cannot be renewed, basically the opposite of a renewable resource. Some types of non-renewable resources are metal ores, fossil fuels, Coal, petroleum, natural gas, and groundwater in certain aquifers are also considered non-renewable resources. Some renewable resources in terms of hydrology are hydropower, tidal power, and wind turbines. Some types of non-renewable resources in terms of hydrology is natural gas, groundwater in certain aquifers. The next standard, the retake of standard A, is explain that a large portion of the Earth's surface water consisting of oceans, rivers, lakes, underground water, and ice. This basically means that most of the water on Earth is on the surface, such as oceans, rivers, lakes, underground water, and ice. This water would be accessible to us, but we cannot use most of this water because most of the water, the largest body of water, is oceans, and all oceans mostly consist of salt water, which is inhumane for us. Next up, we have relate various atmospheric conditions to stages of the water cycle. There are many atmospheric conditions that can happen. For example, when a cold front meets with a warm front, that usually can cause a natural disaster or very severe thunderstorms. This also affects the water cycle because the more heat that is in the atmosphere, which means that the more humidity will be in the air because a lot of water vapor will be in the air because the heat is inducing that water into water vapor. The next standard says, describe the composition, location, and subsurface topography of the world's oceans. We have two main oceans in the world, Pacific Ocean and the Atlantic Ocean. In the ocean topography, there's many obstacles. In the ocean topography, if you were to walk on the ocean floor, you would start off on the continental shelf. Then you would go down the continental slope. Then you would go up the continental rise. Then you would meet in a mid-ocean ridge. There you will go down the abyssal plain. Then you will go up the abyssal hill. Then you will have an island arc, aka the volcanic island. That's how it would be if you were to walk on the ocean floor. The next standard is explain the causes of waves, currents, and tides. Waves are located on the ocean's surface, and they are commonly caused by wind transferring its energy to the water, and big waves or swells can travel over long distances. A wave size depends on the wind speed, wind duration, and the area over which the wind is blowing, otherwise known as the fetch. Tides, however, are caused by the attractive forces of the moon and the sun's gravitational fields, as well as the centrifugal force due to the Earth's spin. As the positions of these celestial bodies change, so do the surface's heights. Ocean currents can be generated by wind, density, differences in water masses caused by temperature and salinity, variations, gravity, and events such as earthquakes. Currents are cohesive streams of seawater that circulate through the ocean. Now that's all we study as hydrologists, and that's a day in the life of a hydrologist.